Good evening. Tuloy po natin yung ating pag-aaral sa thermodynamics for engineer. Ang topic natin ay heat pa rin tayo. Titingnan natin ngayon yung three modes, no, of heat transfer. Yun yung conduction, convection, and radiation. Tatlo po yan, modes of heat transfer. So, often, engineering designs must consider all three modes. No? Conduction heat transfer exists in the material due to the presence of temperature difference within the material. Itong conduction, nagagamit to sa heat transfer. Kapag ikaw ay designer ng air conditioning or heating equipments, nagagamit ito. Okay? Tapos, it exists in all substance, but it must often associated with solids. Alin, yung conduction. So, yan yung first move, conduction. It is expressed mathematically by Fourier's law of heat transfer, which for one-dimensional plane wall takes the form of Q na malaki, Q dot, may dot dun itaas. Sorry Baray natin. Is equal to K times A times delta T over L. Of course, yung K is the thermal conductivity with units of watt per meter Kelvin or BTU per seconds foot Rankine. L is the thickness of the wall. Okay, ito yung L sa baba. Ito yung K. Tapos yung delta T is the temperature difference. Yun sa taas. Okay, and A is the wall area. Okay, ang sinasabi niya lang kapag ka-illustrate natin, okay, mayroon kang wall. Okay. Halimbawa, ito yung wall mo. Straight yan wall. Mali na yung drawing ko. Okay. Yan. Mayroong Q dyan. Papasok sa kabilang side. Okay, meron siyang thermal conductivity. Constant yan per material. So, nakukuha yan sa experiment. So, nasa table yan. Given dapat. So, mayroon kang temperature dito. Sabihin natin T1 sa labas. T2 sa loob. Ayan. Temperature difference, delta T. Tapos yung L daw is the thickness of the wall. Kunyari itong thickness na to, L yan. Ayan, ito yung thickness. Yung area naman, kapag tinignan mo rito sa side na to, depende, no? Kung drawingin natin yan, malapad yung wall na yan, halimbawa, ganyan. Ayan. Kunin mo yung sukat na to. Diba? Sukat na to. Area yan Kunyari ito ay L. Okay. Hindi, may L na tayo. So, W na lang yan. Width. Ito Ito naman ay h times width is equal to area. Yan yung tinutukoy niya, yung area na to, yung lapad na yan. Lapad kung sa Tagalog, area, no? Yan yung A. Ayan, area of the wall. Okay? So, yan yung ibig sabihin. Often, madalas daw, the heat transfer is related to the common factor R. Okay, ano yung R na yun? Resistivity. Okay? And given by ito, para masimplify lang. Okay? Masimplify. So, may R ka. R factor or resistivity. Okay, let's move on. So, yung pangalawang balik na. Ito yung pipindutin ko. So, ang pangalawang mode ay yung conduction, meron ka ng convection. Convection is a heat transfer exists when energy is transferred from solid surface to a liquid in motion. Solid to liquid in motion. It is a combination of energy transfer by both conduction and advection. Yung advection mo, heat transfer due to the bulk of motion of the fluid. Therefore, there is no fluid motion. If there is no fluid motion, there is no convective heat transfer. So, convection is expressed in terms of temperature difference. Meron pa rin temperature difference, no? And the temperature of the surface. Newton's law of cooling expressed this as Q is equal to H sub C times area times delta T. Bulk fluid temperature minus pa rito sa surface temperature, delta T, difference nila. Okay, continue. Ngayon, magbabaguhin natin yung kulay para hindi tayo magsawa. Okay, tuloy lang yung same color, where H sub C is the convective heat transfer coefficient. Ang unit niyan, watt per square meter Kelvin or BTU per seconds foot square Rankine pagka sa English. And it depends on the properties of the fluid including its velocity. So, depende sa fluid na gagamitin mo, no? Yung materials. Anong klaseng fluid yon? Water ba yan? Yan ba ay oil? Diba? Wall geometry. So, yung free convection occurs due to the temperature difference only, whereas forced convection results from the fluid being forced as fan. Yung pangatlong mode ay yung sinasabi nating radiation. Okay, yung radiation is an energy transfer as photons. Okay, as photons, it can be transferred through a perfect vacuum through a transparent substance such as air. Radiation, parang radiation ng araw, no? It is calculated using the Stefan-Boltzmann law and accounts for the energy emitted and energy absorbed from the surroundings. Ito naman yung kanyang formula. Q is equal to ayan, Stefan-Boltzmann constant. Ay, ito yung value. Ito yung symbol. Yan siya. Area, same. Area pa rin yan. At meron siyang emissivity, no? From 0 to 1 lang ito. Itong naunang binanggit niya dyan. Area, may area ka pa rin. Tapos delta T pa rin to. Pero to the fourth power. Yung mga T, no? Okay. 1 for the black body. A body that emits the maximum amount of radiation. And T surrounding is the uniform temperature of the surroundings. Temperature must be absolute temperature. Okay, so radiation, convection, yung 3 modes, okay, na ating pinapag-aralan ngayon. So, tuloy natin. May example dito. Example 3.9. A 10-meter long by 3-meter high wall is composed of insulated layer na given yung R. Given yung R. R is equal to 2 meter square Kelvin watt per watt, and a wood layer with R is equal to 0.15 cubic meter Kelvin per watt. Estimate the heat transfer rate through the wall if the temperature difference is 40 degrees. Delta T na yan. Okay, delta T. Ibig sabihin, delta T. Okay? Itong 40. So, what to do? What to do? Ito yung solution. Solution, the total resistance to heat flow through the wall is ito. R total is equal to R insulation plus R ng wood. Given yung R insulation, which is 2, ayun, plus R ng wood, which is 0.5. Ito yung R total. So, the heat transfer rate is then, yung Q mo, is equal to R, A divided by R total times delta T. Mayroon kang area? Yes, given. 10 times 3. 10 times 3 yan. Plug in the value. Okay, 10 times 3 ba? Yes. 10 times 3. Divide by what? R total. Kasusolve lang natin. 2.5 times what? Delta T. Given na yun. Perform numerical calculation. You will have 480 watts. Okay? Note that delta T measured in degrees Celsius is the same as delta T measured in kelvins. Parehas lang yan pagka delta T. Okay? Parehas lang sa yung degree Celsius at saka degree Kelvin kapag ka delta T, kasi nag-minus ka. Pag hindi ka nag-minus, you have to plus 273 para maging Kelvin yung degree Celsius. Since ito ay may difference, para yung mawawala yung ano mo yung degree Kelvin mo kabila, ganun din yun. Plus ka sa halimbawa ito ay T1. Okay, itong delta T, halimbawa ang formula niyan ay T1 plus si absolute mo plus 273 minus T1 yan, no? T2 halimbawa time plus 273 73. Kasi plus mo yan para maging absolute. Pero mangyayari, ayan o, positive 273, negative 273, cancel out. So what left? Yung degree Celsius in temperature. Kaya therefore, pagka yung delta T equal lang yung degree Celsius sa degree Kelvin. Okay, walang significant diyan na mangyayari. Okay, continue tayo. Tuloy na natin to. Kung meron pa. Okay, meron pa nga. Meron pa ulit. Example 3.10, the heat transfer of 2 meter diameter sphere at 25 degrees Celsius air stream over a time interval of 1 hour is 3,000 kilojoule. Estimate the surface temperature of the sphere if the heat transfer coefficient is 10 watt per square meter Kelvin. So yung heat transfer mo, ito yung formula given. So you have to memorize this. Plus, okay, Q is equal to H sub C times area times delta T na to, at saka may delta T pa rito. Okay? Or, pwedeng 3 times 10 to 6, given kasi yan eh. Okay, ano? Is equal to 10. Yun. Times area. Given by area. Saan ba tayo? Hindi, mali. 10 times 4 pi times 1 square. So, area lang ito. Times delta T. Oh, sorry. Times quantity TS minus ito, given to eh. 25. Yan, given. Given to 25 na to. So, pinlagin niya dito. Okay? Then, ano lang to? Algebra. So, manipulate that. The surface temperature is calculated to be 31.6 degrees Celsius. Okay, note that the surface area of the sphere is 4 pi r square. Ito yung sinubstitute niya dito. Area yan. Ayun. Ang alin? Ng sphere. Sphere yan. Parang bola. Basketball. Ball. Yung bola parang basketball. So, yun yung sphere. Hindi bilog ah. Yung bilog kasi circle yun. Okay? Meron pa isa. Isang problem pa. So, ito. Last problem na lang to. And then we're done. So, estimate the rate of transfer from 200 degrees Celsius sphere which has the immiscibility of 0.8 if it is suspended in cold volume maintained at negative 20 degrees Celsius. The sphere has a diameter of 20 centimeter. Okay, yan yung problem. So, estimate daw natin yung Q transfer from 200 degrees Celsius sphere na mayroong immiscibility. So, ano to? Radiation. Diba? Nagbigay siya ng tagi-isang problem sa bawat mode of transfer. So mayroon tayong formula. Direct substitution ang tawag dito. No? Okay? Yung immiscibility is 0.8. Ito yun. Ayan siya. Yung area is Dapat uh, suspended cool volume maintained negative. The spare has diameter of 20 centimeter. So, meron kang area niyan ito. Okay. Tapos, meron kang temperature na siyempre, pinlog in mo yan. Ano ka dyan, nag plus 273. Tapos, i-raise mo kasi yan to the fourth. Kaya dapat mag-absolute ka muna bago ka mag-perform ng power calculation. Tapos, pag nakuha mo na yan, saka mo ngayon yung minus. Okay, tapos ito naman, ito yung ito. Okay, yan yung 5.67 times 10. Raise mo sa negative 8. Negative 8. Okay? Yan ay constant. Perform numerical calculation. Then you will have 262 joule per seconds. So, balikan natin yung 5 point, sorry. Okay. Ngayon, ito. Constant yan. 5.67 times 10. Sorry, times 10. Raise mo sa negative 8. Okay? Yan yung ginamit niya dito na value. Doon sa mga nagtatanong saan galing yan. Constant yan. Okay, that's all for tonight. Thank you very much.